Hey everybody. So now that we've been in this unit for a couple of videos now and you guys have gotten pretty comfortable with histograms, today what we're going to do is we're actually just going to be comparing our histograms and we're going to be looking at the same data represented in other types of graphs. Today we're going to talk about stem and leaf plots, line plots, and circle graphs and compare the data represented in those things to the histograms that we've gotten comfortable with. So go ahead and be taking notes right here, the bulleted points that so far we've been talking about how data can be represented in frequency tables and histograms. That's what the unit's been about so far. Today we're going to be comparing the data that's given in a line plot, circle graphs, and stem and leaf plots. Okay, so the data that we're going to be looking at can be represented in all these different types of graphs. You'll notice that sometimes we call them plots, sometimes we call them charts, sometimes we call them tables, but this is all the different ways that we can be representing data, okay? Now, first thing I've got here on this page is just some examples, so you can kind of put your pencil down for right now and just watch this part. What I've got here is an example of a line plot, and all we show on a line plot is the number of times something happens. So we're looking here, it looks like, at the number of hours spent reading last week. We have down here hours spent reading, and the height here shows the number of students. So for example, we have 1, 2, 3 students right here who only read for 1 hour last week. Now, when we look to see the most hours read last week, it looks like 5, and it looks like 2 students did that. So what we can do with a line plot is we can just count up all these X's here to get the total. So for example, these 3, then we've got 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's where I got the 20 total. Now we can take this information from the line plot and we can actually put it down here in the circle graph. And I'll show you guys how this works. For the 1 hour, you see this 15% here in your notes. So we get this by doing the 1, 2, 3 students. There's 3 students in this category, 3 out of the 20. And when we do 3 divided by 20 in the calculator, if we do 3 divided by 20, that's the 15% right here. All right. Now, if I do the next one, the 1, 2, 3, 4, 5 students, it looks like 5 students read for 2 hours last week. So if I put the 5 students out of the 20 total in this category, some of you are already going to see that that reduces to a fourth. But again, you can just take the top and divide it by the bottom, and that's where they're getting the 25%. So all we do is take the section that it's talking about and divide it by the total, and that's how we can get the percent for the pie chart, okay? I'll do one more. Let me do this one right here for 4 hours. We had 1, 2, 3, 4 students in this category. So the 4 out of the 20 right here, when we do 4 divided by 20, it is 20%, and you can see that's where we're getting this 20%. So that's how we can take the information from a line plot and represent it into a pie chart. One thing that I want to point out with the two of them is that we can clearly see that the majority of the students here fall into the category of reading 3 hours per week. And you can see right here on the pie chart that that's the largest chunk in the pie chart, which makes sense. So far all we've done is just kind of seen the data and how it's shown here in a line plot. And then I've just shown you again how the information can be translated over into a circle graph or a pie chart. And now right here, I could even take this and categorize this into intervals and say, okay, first let me look and see how many students are reading somewhere between 1 to 2 hours. And what that means up here in the line plot is I now care about these 1 to 2. So I've got 1, 2, 3, 4, 5, 6, 7, 8 students, and that's going to be this category right here. And you can see its height is 8. Let me just erase this real quick from the previous example. There we go. All right, if I cared about the 3 to 4 hours reading, that's right here in my line plot. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see the height here is 10, so that makes sense. And then if we look at the last interval here, students who spend somewhere between 5 and 6 hours reading, and there's no 6 up here, and that's okay, because it's just going to be these two, and that's the height right here, which is these two. And when we add up these 18 plus 2, we can still see that it's the same 20 total that we got from right here. So what we're going to be doing today is we're going to be looking at the data and how it can be represented in the different graphs, and kind of talking about which ones are kind of the most user friendly, and in certain situations when you might want to use one versus another. Okay. Now, as we scroll down here, the last type of graph that I have as an example is something called a stem and leaf plot. And the reason it's called a stem and leaf plot is because over here, the stem is it's like the anchor number. So anything that's in the zeros, meaning like 0 to 10. But right here is when 10 would start. So these are going to be like the teens. These are the 20s, the 30s, the 40s, the 50s, and the 60s. Okay. Now a stem and leaf plot basically just organizes data, and you can see this is now a separate example. These up here all went together with the hours spent reading. These two go together down here. It looks like when we look at money earned in a day, so for example, down here, this person is earning $61 in a day. We've got another person who earned 62, another 62, there's a 63 and a 68. So this right here, this key, it kind of teaches you how to read the stem and leaf plot, and it lets you know that if you were to see a 3 over here and then the line and then a 5 over on this side, that the number would be a 35. So for a stem and leaf plot, again, let's just practice getting comfortable with this. If we took this number right here, this and this, that represents a 17 in the data, okay? If I took this 4 and this 0, that represents the number 40 in the data. Up here when the stem is 0, we've got the numbers 3, 6, and 9 that would also be in the data set. 3 is in it, 6 is there, 9 is there. We'd have a 12, a 15, a 17, and an 18, and so on. Okay, so that's how the stem and leaf plot works. Now again, the data can be organized into intervals, and when we look here, the first interval is from 0 to 9. So from 0 to 9 here, we've got 1, 2, 3 numbers in that category. So you can see that's why the height here is a 3. All right, let me just erase these real quick. Boop, here we go. And let me just pull like another category. For example, let's do the 30 to 39 category. 30 to 39. So anything from 30 to 39 is going to be right in here in the 30s. So we've got 1, 2, 3, 4, 5 numbers that are in this category right here. And that's why the height of this one is this 5. So if you take the heights of each of these and add them up, so we take this 3, we've got a 4 here. We've got a 2 for this one. The frequency here, the height is a 4. And for this category, it'd be a 5. If we add all these up, I've got 5, 10. Then I'm going to do 4 and 4 is 8. So I'm going to get that 8 plus 2. That's going to be, that's right there. That's another 10. So far 20. And then this would be 23. So we've got 23 numbers total in our data set. And we can confirm that over here by just counting. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So you can see here that we have 23 data points in the stem and leaf plot. We have 23 data points in the histogram, so it does match up. One thing I want to point out is that later today in your check for understanding, there's going to be a stem and leaf plot and there's going to be a histogram, and you've got to try to find the category on the histogram that has the wrong thing. Now this one does match up perfectly, but what I'm saying is, let's say for example that next to this 24 and this 26, let's just say in the stem and leaf plot, let's just pretend there was a 7 here. That means there's a 27 in the data, and if we were to look over here, you see how the height is only a 2? That would be the error right there. And what would need to happen is we would need to increase this bar right here and shade it in. And now everything matches up, and this would have 3 in this column, and there'd be 3 in the category right there. Okay. But I'm going to erase that now because I don't want anybody watching to think that there was a mistake. I'm just pointing out that later on in your check for understanding, you're going to have to find the category that has the wrong height. Okay. All right, let's go ahead and flip over now. And at the top of this page, what we're going to be looking at here is a scenario, and we're going to talk about the different ways that you can represent the data in some graphs. So the first graph that we're going to look at here, the ultimate goal is to show the data into a circle graph. Now I do have a circle graph already over here. This circle graph is broken up into 5 equal parts, and where I have it really lightly drawn so that we can use these little chunks as markers to kind of get the appropriate sections for each of these categories. So this is a really important part of the video. Make sure you've got your pencils ready to go. And what we're looking at here, y'all, is just somebody collected some data and said, what are the different kinds of pets that they see in a neighborhood? So they just went around and maybe asked people, hey, like, what pet do you have? And it looks like in their neighborhood, there's 7 dogs, there's 10 cats, 2 people have birds, we've got 5 fish, 1 turtle, and 1 ferret. Now I did the math for you and just went ahead and added them all up. If we add up all of these, we can see that there's 26 different pets total in the neighborhood. Now, one thing that you should go ahead and be doing down here is we're going to get our categories listed. I want to point out that these categories are qualitative data. So this is going to be a bar graph, okay? We've got 1, 2, 3, 4, 5, 6 different categories here. And we're going to have the frequency listed over here. We can simply just go by ones. So I'll kind of model that with you guys as you guys are doing this. We've got a 1, and then 2, and so on. So go ahead and be filling out your graph with me. All right, cool. And now all we need to do is simply just draw the bars here. So for the first category for dogs, there were 7, and I'm just going to extend my line over from here to here. And I'm just going to let 2 columns be the height for the bars. And you guys will be able to see here if we do it that way, if we leave a space, there's plenty of room for this, okay? So there's 7 here. For the cats, we have 10. So for 10, notice I'm going to skip a space. And because I have the computer, I'm just going to extend straight lines all the way down so it's nice and perfect. Okay. You can kind of clean this one up a little bit. All right, cool. For birds, there were 2. So we've got 2. Go ahead and be drawing these bars here with me. There were 5 fish. So we've got 5 fish. The height of this one is going to be 5. A friendly reminder again that we've got spaces in between these because these are not intervals. For a histogram, there shouldn't be any spaces, and we're going to see an example like that down below in a second. Just 1 turtle and 1 ferret. Again, you can see the way we did that, it worked out perfectly where we've got 1 space in between everything. And I'm going to just come through here while you guys are finishing that up, and I'm just going to highlight, we've got 7 in this category. We had 10 here, so your height of this one should be 10. We had a height of 2 here. We had a height of 5 for this one. There we go. And we had a height of 1 for these last 2. Okay. Now this part's actually pretty simple, and you guys even did a bar graph review before we even technically started this unit. So I feel like this part's actually not so bad, but what I really wanted to focus in on is then how to take this data and represent it in a pie chart, all right? Now the first thing that we're going to do is we're going to just get the percentage for each of these. We're going to see what percent of the 26 are dogs. And to do that, we're just going to take the 7 and divide it by the 26. And when we do 7 divided by 26, I'm going to round that right there. I'm going to bump that up to a 27% because of this 9 right here, okay? So there are 27%, which were dogs. Okay, so just jot that down with me. Now the 10 cats, we're just going to do 10 divided by the 26 animals. And that's going to stay, the 4 won't change this, so this is going to be 38%. Okay. Now 2 of them were birds, so 2 out of my 26 animals. And if I move that there, you see how we've got this 6? So this 6 is going to bump this up to an 8, so that's going to be 8%. 8%. Now we're going to do 5. We're going to do the 5 divided by the 26. All right, so that's going to be 19%. 19%. And the answer I get for the turtle will be the same answer for the ferret since they're both just 1 out of the 26. And we are making this a percent now. And we can see again, because there's an 8, we're going to bump this up to it'd be a 3.8, so it's going to be a 4%. 4%. Now in the pie chart, I copied it for you guys so that you'd already lightly have it broken up into 5 sections. And if we know the whole thing is 100%, like it makes up the whole pie chart, if I break it up into the 5 sections, each one of these sections, as it is right now, represents 20%. If we'd left it just like it was, this would be 20%, 20, 20, 20, 20, and this would be 100% total. So the reason I did that is because 20 is a really good marker to kind of look at with these numbers. And the first thing that I want to point out is that this number right here, 19%, that is really close to being a 20%. So we're going to just take one of the sections and we're not going to let it fill up the whole section. I'm going to retrace this one, but instead of retracing this, notice that I'm just going to cut it by just a little bit. And that's going to be our very first section here. We've got the 19% already done. That's the 19% that's going to represent the fish. Now the next thing that we're going to cover here is we're going to take this chunk, which is 20 full-on percent, and I'm going to break the 20 into 5 little parts, because that's going to be, if you do 20 divided by 5 little parts, each part represents a 4, and that's going to be perfect for representing these things here, okay? So to kind of help with this one, I'm just going to kind of guide you guys to where I'd put some little tick marks if you just want to watch in the video. See how I just put those little lines there? Those are my 4 little tick marks, and what that allows me to do is it takes this chunk, which was a 20%, and it now is going to break it up. That's going to be 4. This is 8. That's going to be my 12. That puts me at 16, and this would be the final 20%. So I just broke this thing up into 5 little parts. And again, the reason I did that is because now I've got this 4% that I can say goes right here. And then the next chunk right here is another 4%. Okay? Now I'm going to just type it, but you can write it. So one of those chunks represented turtle. And I'm going to just shrink that down so it fits. All right, so that was the chunk that represented the turtle. And then we had the chunk next to it represented the ferret. And then over here, this chunk, that 19% we've already got, represented the fish. So we can label that one. So I'm just teaching you guys now how to just go and make a pie chart. And you're going to see it's really not that difficult. We've already got 3 of the categories taken care of. Okay, so we've already taken care of those. Now, if you look carefully, this is 8%. So I can just use 2 of these, and I'm just going to now get rid of this line. Okay, so then these 2 together, that would have been 4 and 4. So now this is 8%. Right here, this chunk represents 8%. And that 8%, we now took care of the 2 birds that were in the neighborhood. So I'm just going to label that for birds. All right. Now we know that we still have a 4% left over right here that we haven't assigned to anything. And these are basically what we're looking at that's left over. We've got a 27% and a 38%. Now what I'm going to do is I'm going to just remove this line right here, okay? And you can see that that's that 20% chunk that was right there. So I've got 4% and then this is 20. And so far, if I had this whole chunk right here, that'd be 24%. And for this category, we need 27%. So all I'm going to do is just kind of imagine, if you just kind of want to watch this part, I'm just going to imagine that this one was broken up into 10. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9. And what I've just done here is let this be like a 10. Each of these right here is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20%. So each one of these now is just representing 2 more. So this is 4%. This is 20. So I need 20. So we have 24 so far. 25, 26, and then basically almost to right there would be the 27% right there. And what I'm going to do is I'm going to highlight that chunk from here to here. This yellow chunk, which is that 20% section, this is a 4. We've got a little bit more here. That represents this 27%. Now, when we look at what's left over, it's this 38%. And you can see here in our pie chart that we have this full on 20 chunk. There we go. We have this full on 20, which is right here. We have one left over from right here, so this is 21%. And this right here is what would be spilling over to get to 38. So we said we already had 21, and then this would be 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. This gets me to 36, and then like 37, and then halfway right there, that was the 38. So this right here is the 38% chunk that represents the cats. And we've got that chunk right there. So your circle graph might not be perfect, but I just wanted to kind of point out that if you can kind of visualize the 5 sections in the background, you can use a little bit less here for 19%. I just broke it up to get the smaller numbers. And then even just if it has to be an estimation, that's okay. But we said this one right here was the 27% for the dogs. And it looks like the most popular animal in this neighborhood happens to be cats at 38% right there. We can see that cats are the most popular over here as well. And we can again see that there is a height of 10. And when we did the 10 divided by 26, that's where we got the 38%. All right, so that takes care of graph 1. And that one, like I said, I think that this part was a little bit tricky with the percentages, but the bar graph was not so bad. Now down here, we're looking at the second graph. This one's going to move much quicker than the first example, I promise. So here, I want you to go ahead and be labeling the parts of your histogram. First thing is that we need the title. So what we're looking at here, the data is we have scores on a test. Down here, we're going to make some intervals. We're going to put the intervals for the scores, and then the height here is going to be the frequency. So basically, we're going to put the scores, these intervals, they're going to go down here. And then we're going to look at the height as the number of students right there. That's going to be the frequency over here. Okay. All right. Now for the intervals, we can see that we've got 1, 2, 3, 4, 5 categories. And when I look at the graph over here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We've got 15 columns. So all I'm going to do is just break them up. For every 3, I'm going to put a little line. Okay. And the reason I'm doing that is because, again, 15 divided by these 3 give me the 5 categories. So now, and you guys can just be doing this with me, I'm just going to label the intervals. This first one's going to be the 0 through 10. Then we've got 11 through 20. Then we've got 21 through 30. The next interval is 31 through 40. And last but not least, we have a 41 through 50. Now what I had already done here for the frequency, I already went through it and saw here that it had a height of 30. So if we just go by 2s, imagine this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and then we have 30. So if you want to go ahead and label that, and we're just going to now put the data into the histogram. There were 3 in this category, so the height of this one, if this is a 2, 3 is going to be halfway between. Okay, remember it was 2, then 4. The next one is a 12, so the height would be a 12. And of course, my lines aren't perfect. I'm drawing on the computer. Your lines are probably going to be better than mine. For the next one, we had 20, which is all the way extended over from that line. That one's pretty simple. All right, and the next category, 31 to 40, was 31 students. Now this one's going to go off the chart, just barely though, because remember this went up to 30. So if we extend off the chart a little bit, that's the 31. And for the last category, 41 to 50, there were 22. So here's the 20, and then up would be 22. Okay, so we can double check. We look at the heights. We've got 3 in this category. There were 12 in that category. We had 20 in this category, 31 in this category, and 22 in the last category. And now we just put the data into a histogram. So once you've got that, you're all set, and we can flip over and talk about line plots and stem and leaf plots. Now, line plots are really easy and fun, and basically you're just kind of tallying things along the way with X's. What I have here for y'all is a number line, and what the scenario is we're looking at the number of foul shots made by basketball players in a single set of 20 tries. So for example, when somebody shot 20 times, it looks like this person made 12 of their free throws, okay? There was another time when they made 7 out of the 20, another time when they made 17. And you can see here in the data, it doesn't look like any time they went and made all 20 of their free throw shots. Now that being said, on the number line, if we start here at the 7, we can see that the smallest number in our data set here is a 7. And we need to get the number line all the way up to, it looks like the highest number here is a 17. So if we just go by ones, so 7, then 8, go ahead and put this down with me. 9, 10, 11, 12, and so on. Okay. And now we're just going to look and tally the data. So the 12, we're going to put an X here. Then we had a 7. Then we had a 17. So 3 of them so far. The next time they made 10 out of the 20. Then 13. Then 16. Then 11. Then we've got a 9. So you can see here how the data is represented in a line plot. Now we have another 12, so all we do is just put an X on top of the other one there. 15 we haven't had yet. Making 14 we haven't had yet. Making 8 we haven't had yet. Now we have had an 11, and here's 2 more times that they made 11. And then we have a 15. Now to double check, you can simply count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we know we have all of our data represented here in the line plot. Okay? So the line plots aren't so bad. Now when we were taking the data from a line plot and putting it into a stem and leaf, that's what this is. And you can just write the word stem and then leaf. So again, stems are like your teens, your 20s, 30s, 40s, and stuff like that. And when we look at the data, we have numbers less than 10, so we do need a 0. We have numbers in the teens, so we definitely need a 1. But we would not need a 2 because we don't have any data here in the 20s. They didn't make all 20 shots at any point, so we do not need the 2, okay? Now for the stem of 0, that's going to be the 7, the 8, and the 9. So I'm going to put a 7, an 8, and a 9. Now the number of shots made that were in the teens, we have a 10. 1, 2, 3 11s. So this is an 11, 11, 11. We have 2 12s. We have a 13. We have a 14. You can see I'm starting to run out of room. We have 2 15s. So this is a 15 and a 15. I'm just going to move this over a little bit. Let's see if I can create a little more room for myself. Last 2 data points. So we'd have a 16 and a 17. And looking at the data, we can see here, if we split it, you could say, okay, these are the number of times that they made 10 or more. These are the number of times that they made less than 10. So we could see 3 would fall into this category. And then we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times they got 10 or more. So again, stem and leaf plot, you're just taking the data and kind of organizing it into the teens, the 20s, the 30s, and then down here, this would be anything that's in the ones, okay? I know that sounds weird because there's a 1 there, but that's why I started by saying like the teens, you know, like this would be a 13, a 14, and so on. And if you had anything down here, that'd be in the 20s. Anything here would be in the 30s, but again, we don't have any data there, so we don't need that. So that takes care of a line plot and stem and leaf plot and how to represent the data in each of those and kind of how to read through it. And you might see, again, another question later on where if I put like another X here, it's like, okay, so where's the mistake in the stem and leaf plot? And you're like, all right, well then there should be another 3 over here. Okay, stuff like that. All right, now this next one, graph 4, this is scatter plots. And these are incredibly easy. Scatter plots are actually, you see I have a little star next to it. This is something that we might be looking at later on this school year if we have a chance to get to it. But if not, like I said, it's super simple and I just wanted to show you guys one. First thing that we're just looking at, we got comparison of different shoe sizes and the age for 10 females. It looks like we've got the data here for 10 people, okay? Now the first thing we need over here is a title. And notice that I put the word verse here, like I've got shoe size versus age. And that's because a lot of times with scatter plots, we want to see if we can notice a trend. We want to see if maybe like the older somebody's getting, maybe their shoe size is increasing. But I think you guys already know that that was only true up until a certain age. And once you reach a certain age, your foot stops growing. So that's kind of what happens here with a scatter plot is we try to look for trends in the data and by looking at where the points all fall. Now, what we need down here on this x-axis, if you guys want to write it in, we're going to put shoe size down here. Shoe size goes down here. Let me move that for the last example there. Shoe size is down here, and then we're going to put age on this axis. And for shoe size, we're just going to label them by 1. So this would be a shoe size 1, 2, and so on. All right, and this is going to get us to 10. And then here for the age, looking at the scale, the oldest age in the data, it looks like is a 50. And the youngest age in the data here is a 7. So on the scale, I'm just going to go by 5s because that should give me enough room. So if this is a 5, this would be 10. 15, this would be 20. 25, this would be 30. 35, this would be 40. 45, this would be 50. And that would get us to 55. So it looks like someone who is 9 has a shoe size of 4. So someone who is 9 years old, which is barely under the 10, they have a shoe size of 4. Okay. If the shoe size is 8, this person was 27, so shoe size was 8, and I'm going to go up to 27. Kind of just estimating right there. Shoe size of 5 had a data point of 13, so 5, I'm going to go up to 13. If your shoe size is 7, this person here was 50 years old, so I've got a 50, and I'm going to move that over to 7. Looks like this 20-year-old had a shoe size of 9, so the age here is 20. Shoe size was 9. We have here a shoe size of 3 for an 8-year-old. So the age over here, they're 8, and it looks like their shoe size was 3. Excuse me. We have a shoe size of 10 for a 23-year-old. This 42-year-old person has a shoe size of 8, so another shoe size 8, I'm going to go up to 42. And a 7-year-old here has a shoe size of 1, so a 7-year-old, a little itty bitty foot. And then we have a 14-year-old whose shoe size is 6. So 14, and the shoe size over here is 6, so that would be for the 14-year-old about right there. Now that the points are all plotted here, we can see why they call this a scatter plot, because the points are kind of scattered all throughout. Now, one trend that I think we would kind of notice is that overall it kind of seems like the as your shoe size is getting bigger, we kind of see kind of this upward movement of the points. So as your shoe size is getting bigger, it should make sense that you're getting older. And again, we kind of mentioned already earlier in the video that once you get a certain age, obviously your foot stops growing. All right, now this example down here, I'm going to actually, this is something that's done in class. And if I haven't done it already with the class, then I'm going to be doing it with you guys after you guys have a chance to take some notes here. But I might have already done it too. It just depends on the day and it depends on the class. So that concludes this video. This one will be an in-class thing, and that takes care of everything. So thank you for watching.